All right, welcome everybody. In this video, we are going to wrap up this Colab notebook. This is the last video to go along with this Colab notebook, and there is a link to this Colab notebook in the description of this video. We've been working with data frames, how we can load data frames, how we can slice data frames using indices and logical statements. And so in this very last video, I want to talk about how we can slice data frames using the subset function in R, in base R. And so the data frame that we're going to work with is a large data frame of a bunch of sales transactions from a bike shop. And if you're just opening up this Colab notebook and you haven't run any of the code cells from the previous videos that go along, you're going to get some error messages because you need to define this data frame bike clean. So that's going to require you to run two code cells in this notebook. So let me show you where to run those in case you're just opening this up for the first time. So the first code cell that you're going to want to run is the code cell where we load the data from this external comma separated file. So there is a section in the notebook which is called loading CSV files with the read CSV function. So you're going to want to run this code cell right here, which imports the data into a data frame called bike store. You don't need to run this summary command. There were some issues with the data that needed to be cleaned up. And so if you run this this code cell in the section that's called cleaning the bike store data, this will remove all of the observations that had missing data. This will convert all of the kind of the categorical data to factors, and it's going to just keep a subset of the variables that we're interested in. And so if you run this second code cell over here that cleans up the data, creates this data frame called bike clean, and you're looking at this summary output over here, you're now good to go. And the end of this notebook should work just fine for you. So let me scroll down to the end of this notebook, and now we're ready to work with the bike clean data frame and use the subset function. So the subset function is a nice way of slicing the data using logicals very similar to the way that we did in the previous video that kind of worked through like question 4 up here, possibly in a more intuitive way. So this subset function is in base R. You don't need to like import any packages to use this function. And there are various options that you can use with it. So if you have some questions about the subset function, I would definitely encourage you to run the question mark subset command. This is going to open up the help documentation for the subset function, and you can read through the documentation to read about the various options that are available. But I'll kind of discuss the main ones in this video. So we'll create three different subsets of the data using the subset function. So the subset function really requires like two inputs at its simplest. First, we need to indicate what is the data frame that we're going to be subsetting from. And so in this case, that's the first input that goes into this function. So for us, we're going to be subsetting from the data frame that we named bike clean. So bike underscore clean, that's our first input into this function. And then we have a comma. The next input that I have here is a different way of entering this logical test. Next, I'm going to say, how are we going to subset the data? What's the logical condition that we're going to use to subset the data? So in this case, I want to subset the data. I want to slice out just the observations from bike clean that have a product line which is equal to road. And again, I'm doing the logical operator for equal to, which is two equal signs. So this is a double equal sign. And then I want the product line equal to the character string road. So that's why I put it inside of quotes. And this is going to be assigned to what I'm going to call road version 1. So this is going to be exactly equivalent to what we did in 4a up here, which was pull off all of the observations in byte clean that have a product line equal to road. So that's going to do exactly what we did here. It's going to pull off all of the observations that have product line equal to road. Just maybe the syntax is a little bit nicer. We just say the data frame over here and then the logical condition over here. Let me break this up and I'll run this code cell over here. Nothing happens because I didn't ask for any output to be printed out. But then we can check the output over here. We can see that did exactly the same thing that 4a did. In version 4.2, we've got the byte clean data frame, and we're going to pull off the observations that are equal to road, and maybe we don't want to pull off all of the columns, so we just enter, maybe we just want to pull off some of the columns. So this would be the equivalent of entering like just some of the columns that we want to pull off. If we don't want all of the columns, we can enter a list of the column names that we want to select. So here we would just say select equals, and then we would enter a vector of the names that we want to select. And here, the names we do not put in quotes. So we don't put the column names in quotes here. So let me run this command, and then we can take a look at what the output looks like there. So this kept only the observations that had road, and rather than keep all of the columns like the previous command did, this only kept the two columns, list price and product line, like that. And it's important to note here that when we were doing kind of the logical condition, we do the double equal sign. And when we're setting options like, hey, which things do you want to select? We just do the single equal sign. And one last option might be, okay, I want to go into the byte clean data frame. Let's say I want to select only the price, the list price column. And I only want to select observations that have product line that are equal to road. But rather than like keep the output with a structure of like a data frame structure, there are some occasions where you want to store the output as a vector instead of a data frame. So you want to slice off a subset of the data, and you want to store that data with a data structure of a vector as opposed to a data frame. So we'll see some situations where that will be useful. And we can do that by adding the option drop is equal to true. And so this is going to drop all of the column names, and this is going to store the object as a vector instead of a data frame. So again, running this code cell doesn't print any output to the screen, but it did create this object road underscore version 3. And you can see here that it did just kind of store all of these values now. Instead of storing them in a data frame, it just took all of these list prices and it's now storing them as a vector. There's no name for this vector. So it has a different data structure that's being where it's being stored. And one last thing to mention, and that is we can combine logical statements in a subset command if we have multiple conditions that we want to use, like product line is equal to road and the list price is less than the average price, where this 1034, this, what makes this number significant is this is the average list price. We just do it the same way as earlier. We just combine them with the and operator, the ampersand over here. So this would say we're going to go into the data frame byte clean. We're going to just select off the columns with these two columns with names list price and product line. And we're going to select the rows that have product line equal to road that satisfy both of these conditions, product line equal to road and list price is less than the average, which was $1,107.34. And we can check that. Okay, so that is a wrap on this module on data frames and loading data frames from external files and how we slice them and how we index them and how we use and logical statements and how we can use logical statements to slice and subset data frames. Okay, thanks everybody.